الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضة لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الجبر and solid geometry. طبعا الدرس ده مهم جدا. complex number دي طبعا الأعداد المركبة دي مهمة جدا جدا، لأن طبعا احنا عارفين إن الأعداد دي موجودة من قديم الأزل، وعلم الرياضيات بيكتشف كل شوية أو كل فترة مجموعة من الأعداد أو مجموعة من الأرقام. طبعا الأرقام كلها بدأت من اللي هي الأعداد اللي هي الكاونتنج نمبر اللي هي 1 2 3 4 and so on. بعد كده في مشاكل حصلت، مش عارفين الفرق بين البوزيتيف والنيجاتيف، فاكتشفوا انتجر نمبر اللي هي البوزيتيف والنيجاتيف وزيرو. افتر ذات لقينا برضو في حاجات مش موجودة في الانتجر نمبرز زي الفراكشن او الديسيمال، فجابوا اعداد تانية سموها الراشونال نمبر اللي هي الكيو set of A over B such as A و B belongs to Z and B not equal 0. after that عرفنا ان في برضو كيو داش اللي هي الراشونال نمبر. after that عرفنا ان في اكتشفوا اعداد تانية جديدة اللي هي الموجودة الريل نمبرز، بتضم كل النمبرز اللي قبل كده اللي هي الناتشرال نمبر، انتجر نمبرز، بعد كده الراشونال نمبر. after that after real numbers لقينا في حاجات مهمة جدا ومش موجودة زي السكوير روت 3 or cubic root 4. number has not square root has no cubic root، قلنا ديت ممكن نسميها الراشونال نمبر، وبعدين لما عملنا لها يونيون مع الانتجر نمبرز يبقى سميناها كومبلكس نمبر، وده موضوع درسنا النهارده اللي هي الاعداد المركبه اللي هي كومبلكس نمبر z equal x plus yi. Welcome my dear student in our math program for second 3. Today we are taking complex number. Look at my dear student how to represent z1 3 plus 2i in arranged form. z2 2 minus 3i. Look at x and y. X represent real number, y represent imaginary number. We know that, my dear student, what is the difference between real and imagine? Imagine I, we know I equals square root negative 1, I square equals negative 1, I power 3 equals negative I power 4 equals 1. But in this example, z1 equals 3 plus 2i. 3 real, 2i or 2 imagine. Look at my dear student. We moved 3 at x and 2 at y. This z1. z2 equals 2 minus 3i. 2 on x, negative 3 at y. Represent z3 minus 2i and its additive inverse. Additive inverse of complex number equals negative 3 plus 2i. Look at z equals negative 3 negative 2i. Look at, my dear student, 3 at x real, but 2 at negative 2 at y imagine. This is z. But additive inverse negative 3 plus 2i. Then this additive inverse lie on the second and the fourth opposite additive inverse. What you mean this additive inverse? This additive inverse imagine of real numbers. Imagine of the original number z3 negative 2i, it's imagined by origin point. Look at z and z1. 3 minus 2i, z1 is additive inverse negative 3 plus 2i. Image of z by the origin point equals z1 negative 3 plus 2i. Note that, my dear student, the 2 points represent the number and its additive inverse are symmetric with respect to the origin point. They are ends of a line segment for which the origin point is midpoint. Represent z and z bar if. What is the meaning z bar? Conjugate. 3 plus 2i. What is the conjugate? 3 minus 2i. Then we have z this complex number has real 3, imagine 2. Complex number or conjugate of the complex number z bar, 3 minus 2i. Look at when represent on argand 3 plus 2i. This is the first. But z bar, what you mean z bar? Represent conjugate 3 minus 2i. Conjugate change of imagine. Change the sign of the imagine. Imagine 2i, negative 2i in conjugate. Look at if we have z equal root 3 plus I and 1 minus root 3i. 3i minus 3, negative 1, negative I. Change each of the following algebraic form into trigonometry form. My dear student, look at the solution. At the first, we have complex number. Root 3 plus I. Root 3 represent x, 1 represent y. The first, we know z, it's a form x plus yi. X equal what? Root 3. Y equal what? 1. Positive lie on the first quadrant. As the form in the opposite figure, this complex number lies in the first quadrant. Look at, my dear student, x equal root 3 and y equals 1. Therefore, what is r? We have radius r x squared plus y squared under square root. Then, by using calculator, therefore, r equals 2. Modulus equals 2. What is the amplitude? Angle between angles them tan, shift tan y over x. Tan alpha, absolute y over x. Y equals what? 1. X equals root 3. Then tan alpha 1 over root 3 over root 3 over 3. By using calculator, find shift tan and alpha equal 30 degrees. Then we have complex number z equals root 3 plus I. The required, when the required? Amplitude or modulus. What you mean modulus? Modulus is r square root x squared plus y squared. R equals 2. But what is the amplitude? Alpha. By using the rule tan alpha absolute y over x. 1 over square root 3 by using calculator, then amplitude equals 30 degrees. Remember, this example multi-choice. As example, r equal 2, alpha equal 60. This is wrong. R equal 2, alpha equal 90 is wrong. R equals 1, alpha equals 30 is wrong. R equal 2, alpha equals 30, this is right. By using steps, the first find x and find y. After that, determine the quadrant which lie in it. Z lies in the first quadrant. Why? Because x is positive, y is positive. After that, we find r, the value of modulus, square root x squared plus y squared equals 2. Then, what is the amplitude? Tan alpha equals absolute y over x. By using calculator, alpha equal 30 degrees. The second, then we put z as complex number r multiply cosine theta plus I sine theta. Z equals 2 multiply cosine 30 plus I sine 30. Remember, my dear student, this is true form. When we put complex number as form R, multiply cosine theta plus I sine theta. Second example. When we have z1 minus root 3i, at the first, x equal what? 1. Negative root 3 is y. Then x more than 0, but y smaller than 0. Positive, negative, lie on fourth quadrant. In the fourth quadrant, add the figure, this complex number lie on it. Why? Because x is positive, y is negative. Z equal x plus yi. X equal 1, y equal negative root 3. Then we deduce that this complex number lies in the fourth quadrant. Then we deduce that R or modulus equals square root x squared plus y squared equals 2. Then we find amplitude by using tan alpha root 3. Therefore, negative root 3 equal negative 60 equals, by using 360 minus 60 equals 300. Then we deduce that z equals 2 cosine 300 plus I sine 300, or z equals 2 cosine negative 60 plus I sine negative 60. This right, this right. Z equals 3i minus 3. 3i minus 3. Remember, what is the x? Negative 3. What is the y? 3. X is negative, y is positive. Lies in second quadrant, negative, positive. X is negative, y is positive. Therefore, R equals square root x squared plus y squared root 18. Root 18 equals what? 3 root 2. This modulus. Amplitude, yes, 10, negative 1, negative 3 over 3. But lies is 45, negative 45 by using 180 minus 45, because lie in the second quadrant 135. Z equals 3 root 2 cosine multiply cosine 135 plus I sine 135. This is complex number. Remember, the complex number must be put as the form R multiply cosine alpha plus I sine alpha. The first cosine, the second, the first cosine, the second sine. The operation between them positive must be positive, not negative. If the sign is negative, we change it into positive by using rules of the first secondaries. We deduce that cosine 135 equals cosine 180 minus 45 equal negative cosine 45. The third, negative 1, negative I. Negative, negative lies in third quadrant. Why? X is negative, Y is negative. Then R equals x squared plus y squared. X squared negative 1 squared 1. Negative 1 power 2 1. Therefore, R equals square root 2. Tan alpha equals negative over negative equals 1. Angle equals 45. But this 45 doesn't belongs to the third quadrant. Why? Alpha equal 45 by using the rule. This example is very important. If you measure alpha equal 45 by using calculator, this right. But in multi-choice is wrong. Why? Because this complex number lies in third quadrant. Is 45 belongs to third quadrant? No. What you do? Yes, we add 180 plus 45 equals 225. Z equals 2 root 2 cosine 225 plus I sine 225. Very important value. Study this. What is the 1 by using complex number? If we put 1 as form r cosine theta plus I sine theta, 1 equals cosine 0 plus I sine 0. Why? Because cosine 0 equals 1. And the required put 1 in as complex number. Complex number z equals r multiply cosine theta x plus I sine theta x, or r multiply cosine alpha plus I sine alpha. Then we deduce what? We deduce that 1 equals cosine theta plus I sine cosine 0 plus I sine 0. Why? Sine 0 equals 0, but cosine 0 equals 1. I equals, by using complex number, cosine 90 plus I sine 90. Cosine 90 plus I sine 90. Negative 1 cosine 180 plus I sine 180. Why? Because cosine 180 equals negative 1 and sine 180 equals 0. Then we put negative 1 as complex number. Its form cosine pi plus I sine pi. Pi is 180. Negative I cosine 270 or cosine negative 90 plus I sine 270 or sine negative 90. These very important values. 1 I, negative 1, negative I. Look at 1 and negative 1. Cosine 0, cosine 180. I sine 0 plus I sine 180. Both I and negative I cosine 90, negative I cosine 270 or cosine negative 90. Plus I sine 90. This is I, but negative I sine 270 or sine negative 90. This important rules. Why? Because these rules find it in examples. Look at change into trigonometry 4, negative 4, 3i, negative 2i. We have three numbers. The first, negative 4, second, 3i, third, negative 2i. How change it into trigonometry form? What is that trigonometry form? R multiply cosine theta x plus I sine theta x. Look at negative 4. Negative 4 equal 4 multiply negative 1. What is the rule of negative 1? Yes, x as student. Cosine pi plus I sine pi. Then we change or convert real numbers to complex numbers. This real -4, but complex 4 multiply cosine pi plus I sine pi. Remember, cosine pi equals -1, but sine pi equals 0. And remember, -1 from the previous rules, -1 equals cosine pi plus I sine pi. In this example, what is the modulus R? What is modulus R? 4. What is the amplitude? Pi. Look, the second, 3i. 3 multiply I. What is the I? Cosine pi plus pi over 2 plus I sine pi over 2, or cosine 90 plus I sine 90. 3 multiply I, or 3 multiply cosine pi over 2 plus I sine pi over 2. Remember, this form is called trigonometry form. We have trigonometry form, Cartesian form, polar form. Look at the third example, -2i. What you mean -2i? 2 multiply -i. Someone say, why don't write -2 times I? Yes, another one answer? Excellent student. We must put 2 times -i. Why? 2 must be positive. Why? Because 2 represent R, modulus. This modulus equals square root x squared plus y squared, must be positive. Why? Because the square root more than or equal 0. More than or equal 0, not negative, is positive. Then R must be put as positive number. -2i put as 2 times -i. After that, we have -i cosine 270 plus I sine 270, or cosine -90 plus I sine -90. Then we deduce that -2i is by using complex number trigonometric form 2 cosine 3 pi over 2 plus I sine 3 pi over 2, or cosine 2 multiply cosine -90 plus I sine -90. This is called trigonometry form of complex number. Look at, my dear student, modify each of the following complex number. Z equals 4 cosine 30 plus I sine 30. Z equals 3 multiply negative cosine 60 plus I sine 60. Z equals -2 cosine 300 plus I sine 300. Z equals cosine 120 plus minus I sine 120. My dear student, look at theta 90 minus 30 lies in the first quadrant. First quadrant belongs open interval 0, 90. Second quadrant 90 and 180 open interval. Third 180 to 170. Fourth 270 360 open interval. In this example, theta equals 60, therefore Z equal cosine 60 plus I sine 60. Number B, theta equals 180 minus 60 equals 120, therefore we put the complex number Z equals 3 cosine 120 plus I sine 120. Don't forget, Z is R. R is modulus of complex number square root x squared plus y squared. But amplitude cosine 120 is alpha is called amplitude angle. Therefore, Z equals 3 multiply cosine 120 plus I sine 120. Number 3, theta equals, in this case, 180 plus 300. 300 represent 120. Therefore, we put Z equals 2 multiply negative cosine 300 negative I sine 300. Why? Because we distribute negative sign to the first term and second term. Therefore, by using cosine must be both cosine 120 plus I sine 120. The fourth number D, theta equals 270 plus 120, 390 represent the first quadrant 30, equivalent 30 degrees. Then we deduce that Z equals cosine 30 plus I sine 30. Remember, my dear student, we can put Z as R modulus R multiply bracket contains cosine 30 plus I sine 30. Why? Because this is the right or correct form of trigonometry form of complex number. Complex number Z equals x plus y I. This is Cartesian form. But in complex number in trigonometry form must be put as R multiply cosine theta plus I sine theta. R is called modulus, but amplitude angle theta is called amplitude. Theta is amplitude or principal amplitude. My dear student, by the end of the lesson, we know that the complex number is very important lesson in our life. Why? Because we represent it in arrogant form as real and imagine. Don't forget, I equals square root negative 1, I squared negative 1, I power 3 negative I power 3 negative I power 4 equals 1. Also, my dear student, we use after that this complex number in matrices and determinant. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.